But here is how we are going to do transformations. So really what we're looking at in this one is it says, create a table of values. No, we're just going to directly graph y equals log 2 of x. And then we're going to use that to graph y equals log 2 of 2x minus 1. So if I was trying to graph the graph in the green box, typically on exam or a test, they're just going to say, can you graph what's in the green box? If you were asked to graph what's in the green box, in your head, first, off to the side, you would do a quick sketch and say, this is my parent graph. The base is 2. So I need to know what log 2 of x looks like. Log base 2 of x. I know that it has an asymptote at x equals 0. I know that all log graphs go through 1, 0. And since the base is 2, I know that this particular one goes through 2, 1. So this would be part A. And part B then, when you want to graph the green equation, y equals log base 2 of 2x minus 1, again, this 2 and this x are part of your parent graph. Those won't be transformations. However, going from left to right, can you see that here you have a 2? Can you see that that 2 is inside the function? Horizontal stretch or horizontal compression? It's a compression. You would multiply x by 1 over 2. And then we have this minus 1. Is it inside the function or outside the function? Is it horizontal or is it vertical? It is vertical. If it was horizontal, they would add brackets here to make sure you knew that it was inside. But those brackets aren't there. Or are they? No, they're not. So we have a vertical translation. This would go 1 down. And we are going to graph our logs just like we did everything else in our transformations unit. We're going to say, if this is the point that I'm starting with, 1, 0, and 2, 1, and then I do stretches and compressions first, then translations. What happens? Well, I need to multiply x by a half. I need to go 1 down. X by a half will give me 1 half 0 and 1, 1. 1 down will give me 1 half negative 1 and 1, 0. The other thing I'm going to look at is what happens to my asymptote. And with a vertical asymptote, stretches and compressions won't change it because it's at 0. The only thing that will change it if you translate it left or right. We don't translate to the left or right, so it's going to stay at x equals 0. So as far as graphing this one, all you're going to do, draw your asymptote, label your points, so we have have 1 half comma negative 1 and 1 comma 0. Keep the same shape of your regular log graph, and this is all that's needed for graphing logs. You just need the 2 points from your original graph, do your transformations just like we did in our transformations unit, draw those 2 points and your asymptote, and you will get your final graph. So I'm going to get you turned to page 400, because I think there's a blank page on 400, and we are going to... Oh, is there a part C? Oh yeah, identify the intercept. Thank you. right? It has no y-intercepts. The x-intercept is at 1, 0. The asymptote is still at x equals 0. The domain, x is bigger than 0. And the range is everything. So if I look at the green graph, yeah. Well, the blue one is also bigger than 0. Because x equals 0 is your non-permissible value. So that's why it's not greater than or equal to 0. And then all the x values are on the right side of that. So x is bigger than 0. So I'll get you to turn to page 400. And I want you to try to graph this one on your own. See what I've done with the blue box? I recognize what's our parent graph. I'll do a quick sketch of that off to the side. So you recognize this is a transformation of a log base 3 of x graph. What does a log base 3 of x graph look like? And then you just have to go through and say, what does the 4 do? What does the 1 do? What does the 5 do? Okay, I'll put up the points to see if your points got shifted in the right direction. And there's the final graph. How did you do? So the asymptote starts at x equals 0. The only way it moves is if you move left or right, and since we move 1 to the left, the asymptote would move 1 to the left. Does that make sense?
Yeah, I just did the asymptote.
Any other questions? Yeah, I'll wait. Everybody else ready for the next one? Yeah, okay. Ready? Okay, here's the next one to try. This one's harder. Just because, not because of the natural log. The natural log, boom, should be easy to graph. The base is e, so you have e comma 1. What's hard in this one is what do you have to remember to do when you have a horizontal stretch and horizontal translation? You have to write it in factored form. So if you thought this was going 2 to the left, it is not. It is going 4 to the left. Because if you factor out the half, that'll change that to a 4. I'll put them up so when you're done you can check. And finally then, where do you put those on the graph? Well, 2e minus 4, you're going to have to estimate what that's going to equal. So remember that e is 2.7. So 2 times 2.7 be 5.4 minus 4, it'll be at about 1.4. Again, label your points, have the general shape of your log graph going through those points and going towards the asymptote.